In college algebra today, we talked about increasing and decreasing functions. So we're still looking at graphs. All we need to be able to do is write down on what interval the graph is going up or down or staying flat. So increasing, decreasing, or constant. This on this first page is a good story about how someone's temperature fluctuates. So in this first paragraph, the person wakes up with a high temperature, and as they're awake, it's steadily decreasing. So it's kind of confusing on the graph because at 0 hours, that resembles 8 o'clock. So like at 1 hour, that's 9 o'clock, 10 o'clock, and 11 o'clock. So from 8 to 11, the temperature is dropping. But let's use that x-axis, starting at 0. So I would describe that graph on the right as decreasing on the interval 0 to 3. And as you see, it's typed right above this. I'm okay with you writing this also. Or if you want to be real formal, you can write it like this, but I'm okay with this. All right, as long as I can tell what x values it's going down. As you read on, this person's temperature starts to rise at 11 o'clock. So at 11 o'clock, that's at 3 hours, right there, right at this spot, temperature starts to rise. So we would say this person's temperature is increasing from the 3rd hour up to the 5th hour. Or like I said, you can write it like that. And then lastly, their temperature levels off, or it just doesn't drop anymore. So starting at the 5th hour, we would say that it's constant. And that's from the 5th hour up to the 7th hour. All right? All right, let's try a real one. This is just describing the whole thing, but a real problem is right here. We have two different problems. We need to describe if and where it's increasing, decreasing, or constant. So I would say, as I scan this thing left to right, use x-axis numbers. So yes, there are numbers on the y-axis, but those will not count for our answer. We need to refer to these up and down movements on the x-axis. So I would say on the first graph, as I read it left to right, it's dropping on that interval right there. Now there's a faded arrow up there. It's hard to see. If there's no starting point for the graph, we're going to use negative infinity. So this thing is decreasing as I read it left to right. No starting point. So I'm going to use negative infinity. But it does stop decreasing, like the graph takes a turn, at 0. So I am looking right at that red dot. So read that thing left to right. There's no beginning, so I'm going to use negative infinity up to 0. Then the graph starts rising, and then it starts dropping again on that interval. So at that turning point, at the second red dot that I've made, it starts dropping at 2. But it never stops dropping, so I'm going to use infinity. I would say that this graph is increasing. Let's color code it. In that middle section. So at 0 on the x-axis until 2 on the x-axis. And that's the first problem. Example 2a. It's never flat, so you don't have to stay where it's constant. On part B, I would say it's constant at the beginning, and there's no real starting point. So that purple line right there, I want to read that thing left to right, and it's constant. No beginning, so I'm going to use negative infinity again. And it's flat all the way until that purple dot right there, which is 0 on the x-axis. Many people want to say the y, but you're only referring to the x-axis. All right? Then it jumps and it starts increasing at 0. So I know there's an open dot right there. We don't really care about that in terms of increasing and decreasing. Just up, down. So at 0, starts going up and it never stops. And that's it. That's all we did on Thursday. Well, we took a quiz, but those were the only notes. See y'all later.